Later, the hypoglossal artery atrophies, and the vertebral is connected with the first segmental artery. The cervical part of the vertebral is developed from a longitudinal anastomosis between the first 7 segmental arteries, so that the 7th of these ultimately becomes the source of the artery. As a result of the growth of the upper limb, the subclavian artery increases greatly in size, and the vertebral then appears to spring from it. Recent observations show that several segmental arteries contribute branches to the upper limb bud and form in it a free capillary anastomosis. Of these branches, only one, viz., that derived from the 7th segmental artery, persists to form the subclavian artery. The subclavian artery is prolonged into the limb under the names of the axillary and brachial arteries, and these together constitute the arterial stem for the upper arm. The direct continuation of this stem in the forearm is a volar interosseous artery. A branch which accompanies the median nerve soon increases in size and forms the main vessel, median artery, of the forearm, while the volar interosseous diminishes. Later, the radial and ulnar arteries are developed as branches of the brachial part of the stem, and coincidentally with their enlargement the median artery recedes. Occasionally it persists as a vessel of some considerable size, and then accompanies the median nerve into the palm of the hand. The primary arterial stem for the lower limb is formed by the inferior gluteal sciatic artery, which accompanies the sciatic nerve along the posterior aspect of the thigh to the back of the knee, whence it is continued at perineal artery. This arrangement exists in reptiles and amphibians. The femoral artery arises later as a branch of the common iliac, and passing down the front and medial side of the thigh to the bend of the knee, joins the inferior gluteal artery. The femoral quickly enlarges, and coincidentally with this, the part of the inferior gluteal immediately above the knee undergoes atrophy. The anterior and posterior tibial arteries are branches of the main arterial stem. Further development of the veins. The formation of the great veins of the embryo may be best considered by dividing them into 2 groups, visceral and parietal. The visceral veins. The visceral veins are the 2 vitelline or omphallomesenteric veins bringing the blood from the yolk sac, and the 2 umbilical veins returning the blood from the placenta. These 4 veins open close together into the sinus venosus. The vitelline veins run upward, at first in front, and subsequently on either side of the intestinal canal. They unite on the ventral aspect of the canal, and beyond this are connected to one another by 2 anastomotic branches, one on the dorsal and the other on the ventral aspect of the duodenal portion of the intestine, which is thus encircled by 2 venous rings. Into the middle or dorsal anastomosis the superior mesenteric vein opens. The portions of the veins above the upper ring become interrupted by the developing liver and broken up by it into a plexus of small capillary-like vessels termed sinusoids, Minot. The branches conveying the blood to this plexus are named the venae advenientes, and become the branches of the portal vein, while the vessels draining the plexus into the sinus venosus are termed the venae revihentes, and form the future hepatic veins. Ultimately, the left vena reverens no longer communicates directly with the sinus venosus, but opens into the right vena reverens. The persistent part of the upper venous ring, above the opening of the superior mesenteric vein, forms the trunk of the portal vein. The 2 umbilical veins fuse early to form a single trunk in the body stalk, but remain separate within the embryo, and pass forward to the sinus venosus in the side walls of the body. Like the vitelline veins, their direct connection with the sinus venosus becomes interrupted by the developing liver, and thus, at this stage, the whole of the blood from the yolk sac and placenta passes through the substance of the liver before it reaches the heart. The right umbilical and right vitelline veins shrivel and disappear. The left umbilical, on the other hand, becomes enlarged, and opens into the upper venous ring of the vitelline veins. With the atrophy of the yolk sac, the left vitelline vein also undergoes atrophy and disappears. Finally, a direct branch is established between this ring and the right hepatic vein. This branch is named the ductus venosus, and enlarging rapidly, it forms a wide channel through which most of the blood, returned from the placenta, is carried direct to the heart, without passing through the liver. A small proportion of the blood from the placenta is, however, conveyed from the left umbilical vein to the liver through the left vena advehens. The left umbilical vein and the ductus venosus undergo atrophy and obliteration after birth, and form respectively the ligamentum teres and ligamentum venosum of the liver. The parietal veins. The first indication of a parietal system consists in the appearance of two short transverse veins, the ducts of Cuvier, which open one on either side into the sinus venosus. Each of these ducts receives an ascending and descending vein. The ascending veins return the blood from the parietes of the trunk and from the Wolffian bodies, and are called cardial veins. The descending veins return the blood from the head, and are called primitive jugular veins. The blood from the lower limbs is collected by the right and left iliac and hypogastric veins, which in the earlier stages of development open into the corresponding right and left cardial veins. Later, a transverse branch, the left common iliac vein, is developed between the lower parts of the two cardial veins, and through this the blood is carried into the right cardinal vein. The portion of the left cardial vein below the left renal vein atrophies and disappears up to the point of entrance of the left spermatic vein. The portion above the left renal vein persists as a hemiazygous and accessory hemiazygous veins and the lower portion of the highest left intercostal vein. The right cardinal vein, which now receives the blood from both lower extremities, forms a large venous trunk along the posterior abdominal wall. Up to the level of the renal veins, it forms the lower part of the inferior vena cava. Above the level of the renal veins, the right cardinal vein persists as an azygous vein and receives the right intercostal veins, while the hemiazygous veins are brought into communication with it by the development of transverse branches in front of the vertebral column. Inferior vena cava. The development of the inferior vena cava is associated with the formation of two veins, the subcardinal veins. These lie parallel to and on the ventral aspect of the cardinal veins, and originate as longitudinal anastomosing channels which link up the tributaries from the mesentery to the cardinal veins. They communicate with the cardinal veins above and below, and also by a series of transverse branches. The two subcardinals are for a time connected with each other in front of the aorta by cross branches, but these disappear and are replaced by a single transverse channel at a level where the renal veins join the cardinals, and at the same level a cross communication is established on either side between the cardinal and subcardinal. The portion of the left subcardinal behind this cross communication disappears, while that in front, i.e. the pre-renal part, forms a connection with the ductus venosus at a point of opening of the hepatic veins, and rapidly enlarging, receives the blood from the post-renal part of the right cardinal through the cross communication referred to. In this manner, a single trunk, the inferior vena cava, is formed, and consists of the proximal part of the ductus venosus, the pre-renal part of the right subcardinal vein, the postrenal part of the right cardinal vein,